All right, let's go do this. So we've been spending all week long on section 4.4. Okay, so what's in section 4.4? Well, there's three main concepts. The first one is the fundamental theorem of calculus. Okay. This is the thing that looks like this. You should be very familiar with this by now. Okay. And so the fundamental theorem of calculus allows you to figure out what an answer to a definite integral is by hand. And by hand, that means that you have to find out what the integral, what the antiderivative of the f prime of x is, and then you have to figure out what f of b is, and then f of a is, and then subtract them. So that's the first thing. The second thing that's important in this unit is the average value. So we have this formula that really is fascinating when you stop and think about it. It allows you to find the average value of a function on an interval. And the reason why I find it fascinating is because there's an infinite number of points. And we're finding the average of an infinite number. Okay? And the average value formula looks like this. It's average value is equal to 1 over b minus a times the integral from a to b of f of x dx. So that's the second big idea from this unit. And then the third one is one that we discovered yesterday. It's actually called the second fundamental theorem of calculus. And it allows you to find the derivative of a function that contains an integral. And here's what the notation looks like. So this says if I have an expression which is an integral, okay, then I can find the derivative of the integral, and in this case, the final answer is f of x. Notice it's not f of t. Okay, and we'll run through that another time. So these are the three big ideas from this, and we have assignment page 291, which is due tomorrow. Okay, so I highly recommend you get all those done so that we can take a look at the questions that you're struggling with. All right, what I want to focus on today is number 3, because we've kind of been doing those other ones. We get us some practice. So let's take a look at number 3. So I'm going to look at it from a couple perspectives. So if I have some function, now I'm going to use different letters so that we can get used to that. So I'm going to use q of t, okay, q of t, QD function. Yeah. And it's equal to the integral from 4 to t of x plus 3, okay, dx. Strategically put the t's in the x's and things like that. Here's what happened. The value here, this variable here, is located in the integral. It's going to be one of the limits. Okay, it can be either one. I just happen to be putting it at the top. This has to be completely different variable. Okay, and there's a good reason for it. And I'll explain it as we do this. So here's what I want you to figure out. I'm going to give you a couple of problems. So the first one I want you to do is I want you to find Q of 4. Then I want you to find Q of 5. Then I want you to find Q of negative 2. Okay. And then after we do this, I want you to find Q prime of t. And you got to do it all by hand. Okay? So, give me the answers to these three by computing it by hand. That first one's actually really easy, right? Did you spot that? Because we know if you start and end at the same place, the interval is there's no space there. So there's no area, there's no change. There's no net change if you never move. Okay, the other ones aren't like that though. Yeah, you do either one. Whatever just naturally seems like a good way to do it. Decimals and fractions are equivalent, so you can do either one. Did anybody else get this for an answer? Okay. Get negative 24? Okay. Now, wait a second. You see how I left this from 4 to negative 2? You notice how it still worked out? Okay. If you said, well, wait a second, the integral from 4 to negative 2 is equal to the opposite of the integral from negative 2 to 4, and you carried it out, you'd still get the same answer. Okay? It still works. It's just that these would have been reversed, and the signs would have then also be reversed so that it all works out. Okay? All right. So here's what I want you to not be afraid of something that looks like this. It's pretty weird looking. It's a function that contains an integral. There's multiple variables. This is all it is you just plug it in. Okay? And then work it out. Now, the last component here is, what is the derivative of this? Okay, what's q prime of t? Okay, so let's do that. Q prime of t is equal to the derivative of this. Now, I'm going to do it the long way to show you how it works out. But you can state right now, what's the answer to this? T plus 3. On the AP exam, if you spot this and you say, oh, the answer is t plus 3, that's good, and move on, as long as it's a multiple choice. Okay? The derivative of this is this. Boom. Again, I'm going to clarify why it is that way right now. Watch what happens. It's very cool. What happens is we're finding the derivative with respect to t, because that's the variable. And we're going from 4 to t of x plus 3 dx. The integration and anti-differentiation integration and differentiation are inverses of each other. That's why we end up with the same thing we started with. Okay? But the variables change, and this is why they change. If you do this, I'm going to leave out the derivative until I'm done. Okay? So this becomes 1/2 x squared plus 3x evaluated from 4 to t. Okay? Okay, do the thing. You know the thing. Doing the thing. We plug in the t, then we plug in the 4, and we subtract them. So we're doing the thing. So it's still the derivative, because we're saving that till the end, is going to be 1/2 t squared plus 3t minus 1/2 times 4 squared plus 3 times 4. That's doing the thing. That's the fundamental theorem of calculus being applied. Okay, at this moment, we can go ahead and take the derivative. So notice, we're taking the derivative with respect to t. Ah, how handy is that? The t variable here is now in the function here, where it wasn't before. But now it is because we plugged in the t. Now we can find the derivative of it, and would you look at that? Derivative of that is t, the derivative of that is 3. The derivative of both of these are 0, so final answer comes out. Yes?
Back to C, so you don't have to, like, put the opposite?
Nope.
When would you have, where would be like a problem?
Well, sometimes it might be a problem in, you know how like it's a multiple perspective one. If you look at it and you're like, well, this doesn't make any sense. It would make more sense to flip it around. Then I'm going to flip it around.
Okay.
But if you want to just crank through it as it is, no problem. Okay. 30. Now, let me show you another perspective about what's going on here. The answer to this one was 7.5. I'm going to keep that in mind. Now, this is really kind of interesting. I'm trying to bring in the visual. What's going on here? And the answer to this one was negative 24. Okay, I'm going to look at this from a visual standpoint. Okay, Now look at this from a visual standpoint. What the heck is going on here? Okay. Well, let's graph x plus 3. Okay. Graph of x plus 3. 1, 2, 3. There it is. And then I'm going to go out 4. 1, 2, 3, 4. Okay. And then I'm going to go out 5. And then I'm going to go back to negative 2. Okay. So this is what I've got. Now, I'm going to graph y equals x plus 3. So this is just this thing right here. Okay. And it goes here, and it goes here. And I think this goes here. Okay. Now, this is pretty cool. What's the integral from 4 to 4? Well, it's the area that's bounded underneath that point. Okay? And remember that points don't have any space, they do not take up any space, so that's why the answer is 0. But now look at this one. This one says, what's the integral from 4 to 5? Well, from 4 to 5 is this right here. See what I'm saying? It says start at 4 and go to 5 and tell me what that area. The area of this trapezoid is 7.5. Okay? It's the amount of change that we went as we went from 4 to 5. Okay? Now, the second one was the integral from 4 to negative 2. Okay? So it's from 4 to negative 2. So that means I'm starting here, and I got to work myself backwards to here. Hello, sir.
I just wanted to see how awesome you were today.
Well,
You look pretty awesome.
hey, can you say that louder into the swivel? That just makes my
I
day.
think Mr. Johnson is pretty awesome today.
I have no pride whatsoever. Okay, so the answer to the integral was negative 24. Okay, but wait a second. That's above. Okay, that's above. What's the deal here? Notice that this was the integral from 4 to negative 2. I went backwards. But the integral from 4 to 2, taken to negative 2, is equal to the opposite of the integral from negative 2 to 4. You see what I'm saying? Therefore, if you said, oh, find the area from negative 2 to 4, we get this. But then we have to take the opposite of it because we're going backwards. Does that make sense? Okay, so we should be able to do these now for any single thing here. We can find the derivative using the second fundamental theorem of calculus, either by going straight to the answer or by working it out by hand. And we understand that this all means it all relates to the graphs. It's all connected. And the more that you see how it's connected, the easier it will be to solve a problem that you've never seen before because you can apply the different techniques. Okay? Now, we didn't get to the last part that I wanted to get to, which is part of what's on page 291, and it has to do with what if this is not just a t, but what if it's an actual function? Okay? What happens there? There's just a couple problems on the end, and I'm going to go through that tomorrow. So if you don't have those done by tomorrow, that's okay. They're the last couple of questions anyway.